So good day everyone, I am Caroline Marie S. Alcala, the 6th reporter of Group 1, and today I'm going to tackle or discuss about the runoff movement. First off, let us define what is runoff. So by definition, runoff is the quantity of water discharged in surface streams. It includes not only the water that travels over the land surface and through channels to reach a stream but also interflow. The water that infiltrates the soil surface and travels by means of gravity toward a stream channel or always above the main groundwater table, a groundwater level, and eventually empties into the channel. Runoff also includes groundwater that is discharged into a stream. Stream flow that is composed entirely of groundwater is term-based flow or fair weather runoff, and it occurs where a stream channel intersects the water table. So the total runoff is equal to the total precipitation less the losses caused by evapotranspiration or the loss to the atmosphere from soil surfaces and plant leaves, storage as in temporary plants, and other such abstraction. So, in simple terms, runoff is the water that is pulled by gravity across the land surface, replenishing groundwater and surface water as it percolates into an aquifer or moves into a river, streams, or watersheds and other bodies of water. So next is the GWT, groundwater table, or phreatic surface. The phreatic surface can be determined from the subsurface investigation with adjustment for seasonal changes. If the slope has not been constructed and is quite complex in configuration, the easiest way to determine the phreatic surface is by drawing a net flow or a flow net. If there is no impeding layer in the subsoil, the infiltrating water percolates into the ground as deep seepage and builds up the ground table. So phreatic surface indicates the location where the pore water pressure is under atmospheric conditions. So this is the water cycle. So water cycle describes how water is exchanged or cycled through Earth's land, ocean, and atmosphere. So water always exists in all three places and in many forms. As lakes and rivers, glaciers and ice sheets, oceans and seas, underground aquifers, and vapors in the air and clouds. So the water cycle has three major processes: the evaporation, condensation, and the precipitation. So evaporation is the process of a liquid surface changing into gas. In the water cycle, liquid water, like in the ocean, lakes, or rivers, evaporates and becomes water vapor. Evaporation process is driven by the sun. As the sun interacts with liquid water on the surface of the ocean, the water becomes an invisible gas or water vapor. And evaporation is also influenced by wind, temperature, and the density of the body of water. So next is the condensation. So the process of condensation is gas changing into liquid. In the water cycle, water vapor in the atmosphere condenses and becomes liquid. Like evaporation, condensation is also influenced by the sun. As water vapor cools, it reaches its saturation limit or dew point. And then next is the precipitation. So precipitation describes any liquid or solid water that falls to the earth as a result of condensation in the atmosphere. So, precipitation includes rain, snow, and hail. And then there are also components, which is the surface runoff, infiltration, interflow, and river discharge, and the base flow. Next is there are two types of runoff movement, the surface runoff and subsurface runoff. So, surface runoff is the water from rain, snowmelt, or other surfaces or other sources that flows over the land surface and is a major component of the water cycle. So, surface runoff can be described as water flowing over soil, vegetation, or other ground cover instead of infiltrating to the underlying soil. And next is the subsurface. Subsurface is the flow of water beneath Earth's surface as part of the water cycle. So in the water cycle, when precipitation falls on the Earth's land, some of the water flows on the surface forming streams and rivers. So what is the difference of surface flow from subsurface flow? So surface runoff or surface flow occurs in the ground surface or water flows over the land surface, while subsurface runoff or subsurface flow is relatively rapid flow toward the stream channel that occurs between or below the surface. And then, so this is the water cycle. So what are the factors affecting runoff? First is the storm characteristics. So storm characteristics includes the type or nature of storm and season, intensity, duration, areal extent, or the distribution, frequency, antecedent precipitation, direction of storm movement. So, storm characteristics is the most important factor for runoff. It depends on the type of the storm and its duration and causes precipitation. So runoff also depends on the intensity of rainfall, because the more the rainfall, the more will be runoff. And if the rainfall intensity is very less and it rains as light shower, then much of the water will be lost in infiltration and evaporation, resulting less runoff. Next is the meteorological characteristics. This includes temperature, humidity, wind, velocity, and pressure variation. So runoff may also be affected by temperature, wind, and humidity. If temperature is low and ground is saturated, then runoff will be greater. If temperature is high and greater wind velocity give rise to greater evaporation loss, resulting in less runoff. So next is the basin characteristics. This includes size, shape, slope, altitude or elevation, topography, geology, type of soil, land use or vegetation, orientation, type of drainage net, proximity to ocean and mountain ranges. So basin characteristics depends upon size, shape, slope, and location of the basin. Generally, more rainfall or smaller area results in greater runoff, and less runoff in larger basin because due to uniform rainfall over the entire area. Thus, only few tributaries of the stream feed water to a main stream during a particular storm. So next is the storage characteristics. Depressions, pools, sands, ponds, lakes, streams, channel check dams, upstreams, reservoirs, or tanks. Floodplains, swamps, groundwater storage, impervious deposits, or aquifers. Low-intensity storm over longer spells contribute to groundwater storage and produce relatively less runoff. So, storage characteristic or the artificial storage such as dams, weirs, and etc. And natural storage such as lakes, ponds, rivers, and etc. tend to reduce the peak flow. They also give rise to greater evaporation losses. Next is the topography. Runoff depends on surface smoothness and slope. If slope is steep, flow will be quick and less evaporation and absorption, resulting greater runoff. If the catchment in the mountainous area and on the windward side of the mountain, then more rainfall resulting more runoff. So I have a short video para mas masabtan.
Water is one of our most essential resources.
But many people don't know where it comes from.
The water cycle is the continuous movement of water on, above, and below the surface of the earth. Water is one of our most essential resources.
But many people don't know where it comes from.
The water cycle is the continuous movement of water on, above, and below the surface of the earth. Surface water is all of the water we see: lakes, rivers, streams, and of course the ocean. Heat and wind cause surface water to evaporate, forming water vapor, which rises into the atmosphere.
Now you see me, now you don't.
The higher the vapor rises in the sky, the colder it gets. The vapor freezes in tiny crystals and forms a cloud. This is called condensation.
I'm flying! Woo-hoo-hoo!
Water falls back to the earth as rain or snow,
My precipitation skills make a big splash!
as the water returns to the surface.
Now, things get interesting, depending on where I land.
That's right. If you land in the ocean, you will eventually evaporate and return to the clouds.
True, but if I land on a high mountain, I'll freeze!
When snow and ice melt, the water either runs off into a stream or is absorbed into the ground.
That water collects far beneath the surface.
We call that layer of groundwater an aquifer.
To complete the water cycle, groundwater seeps back into surface water, and the whole process begins again.
To review. Evaporated surface water rises as vapor, collects in a cloud, and falls to earth as rain or snow. Some of the water runs off into lakes, rivers, or the ocean. Some is absorbed into the ground, where it eventually seeps into surface water.
So that would be all for my report, and thank you for watching.